Okay, hi everyone. This is my extra credit presentation too for this IoT topic is IoT in analytics. So coming to the introduction, the Internet of Things is basically a data analysis a tool which accesses wide range of data collected from the IoT device, and usually the IoT analytic accesses the vast quantities of data produce useful information from it. IoT analytics are usually discussed in tandem and industrial IoT, which is also known as IIoT. So, the data is collected from a wide range of sensors, manufacturing infrastructure, weather stations, smart meters, delivery trucks, and all forms of machinery. IoT analytics can be helped to managing data centers and applications, handling retail and healthcare. In many ways, IoT data is similar to big data. The key difference between two is just not the quantity of data, but range of sources is obtained from. All this data can be processed into one comprehensible single stream of data, considering the several kinds of sources of information. Data integration becomes quite difficult, and this is where IoT analytics make a difference. So, devices that power IoT analytics. So wearables. So dedicated trackers such as Fitbit and other smartwatches have gone beyond tracking steps. You can track your friends' fitness activities and compete with them, message, and even answer the phone by connecting your devices through internet. This information is tracked by fitness companies, enabling them to create customized packages if you sign up. So this include exercise routines, diet goals, and more. So the newest smartwatches even monitor heart rates, rhythms, and have accurately diagnosed heart problems in their wearers. So smart home, we can see the Siri, Alexa, these kind of things are definitely helpful in the smart home, and the automatic lights and automatic system of electrical appliances at a home would be considered as a smart home. And even in healthcare even has a wide range of IoT devices. So Bluetooth uses like to create something like hearing aids and records heart and blood pressure monitors. So even this helped to enhance healthcare into a large extent. So the data which is collected in the healthcare is very secured, and it is also very important. So voice activated everything. So something like Alexa, Siri, and Google take notes, find information, they play music. So these all things can be performed with the power of IoT. So the internet regularly updates this kind of digital assistants to improve functionally, but the data helps companies to tailor their services for you. So that's how devices which provide data and power to the analytics IoT. So how IoT analytics work and the applications. With a wide range of devices, there is an endless stream of data in enormous quantities. So IoT analytics help to analyze this data across all connected devices without hardware and infrastructure. As the needs of your organization change, computing power and data store scales up down accordingly, ensuring your IoT analytics has a requisite capacity. So basically, the first step is like the data is collected from various sources and various formats, and this particular data is processed with a large external sources. So after the external sources data has been processed, the information is stored in the time series for analysis, because everything can be a time strain data. So the analysis can be done in multiple ways with custom analysis systems, the standard SQL queries, or with machine learning algorithms. So the results can be used to make wide range of predictions. With the information received, the organizations can build several systems and applications to ease the business processes. So now, how the business you what are the business use cases of analytics and how are they used? So smart agriculture, which is a very known topic and emerging topic these days, and regular restocking of supplies and predictive maintenance and proficiency efficiency scoring. So with the IoT analytics in the agriculture, we could connect smart devices and smart vehicles and drone farming. This kind of and smart irrigation systems. So these kind of features can be found in the smart agriculture, and regular restocking of supplies. As you can see in the fulfillment centers such as Amazon, and there are a lot of Walmarts and Amazon food uh, places where the robots automatically restock the things. So this can be triggered when stocks and the machine can be reached to a particular level. So predictive maintenance could be of a software and as well as a hardware too. In the industries and as well as a software management, the predictive maintenance is also used. So process efficiency scoring. So every company works with a range of process in a place. So IoT analytics can be measured in the efficiency of this process and make necessary changes in them. The results from IoT analytics can be identified by bottlenecks, both current and potential, can increase the efficiencies. So now the benefits of the IoT analytics. So as you can see, we could see a better control and quick decision making with this kind of analytics, and the scaling of the business would be increased when they are into the markets, because they can provide some data which other companies wouldn't be having. So for example, let us take a small company which is health based startup and they are good in analytics, and they can compete with Fitbit and as well as other tracking fitness tracking smart wearable applications, that there is a particular feature we can get track of, and they can get a patent too. So analytics is very useful for the increasing the scale of the business. So reduction in operation costs from automation, so it would be better resource utilization. So if we have analytics and we can know, we can cut down the costs for unnecessary operational costs which are existing in the system. And a new revenue system would be also involved in the operational challenges, quicker solutions from the accurate pinpointing of the problems, quicker resolutions of the issues. This all can be done using the IoT data with the power of analytics. So, and also enhanced customer experience based on the analysis of purchase history. So, suppose for example, if a person goes to a supermarket and he buys at the time of the 8:30 a.m. in the morning, he regularly every Tuesday if he buys some breads, egg and milk, and due to the video processing if of the person, if he automatically enters into the store, that the most predictive item he could take every time would be accessed, and he could be readily delivered when he enters into the store within a minute. So instead of searching the all the aisles in the supermarket, so he could get a box of required things at the entrance point or the exit point itself. So as I said example, when he enters, automatically they would be providing him the bread, milk and eggs. So enhanced customer experience can be done also using this IoT analytics. So quicker, the more relevant development of the product can be also seen in the analytics. So this is the data flow architecture of I've taken example of Microsoft Azure and how the sensor data has been managing. As you can see, this is the blob storage. Blob is a data type which is stored for images, and the stream analytics and SQL database and the web application to represent the data, and the data traffic manager which will make sure that there is a no discrepancy in the data and no data is damaged or lost, and the load balancer will segregate the data and push required amount of data so there is no server breakdown, and the construction equipment will segregate the kind of data. As you can see, the construction results data and as well as the sensor data are being segregated with this equipment. And this is something like in person where you have a virtual machine as a computer or a laptop where you can see the Azure virtual uh, re- uh, you can manage the load balancer from here, and the database server which also uh, keeps on connecting the different sensor readings and the sensor data from the inbound server to the database server when we are sending that. So, and Apache Spark or any technical softwares which are used to push the data into the database, and from with this web app it is connected to the Apache Spark kind of activities. And here the cloud connection is being done here, as you can see. And now this is an SQL database where it sends when the web app will sends the data and create into a blob storage. So this is the architecture of IoT and analytics. So as you can see, there is a lot of variation in the data, like social data, external data, machine data, sensor data, irrespective of the fields. Everything is getting integrated, and there is one whole event server like cloud server, and there is on-premise server which is in the intranet. So rules, aggregation, correlation, tertiation, transaction, and real-time analytics, adapters, streaming the enterprise data, like historical context of the data, in-memory input computation, which is done on the grid basis of the data. Everything is can be seen here. And there is a big data database where all the kinds of data are being compared here, and the real-time analytics put up a result, and the statistical um, events or the analytics have been done, and they push into the business works, and the actions or alerts are given as the outputs. Because as an analytical team or a data engineer or anyone who's using the IoT sensor inputs and converting using them into a data by using a real-time analytics, so they would provide some action to control, or else the alerts where you can, where is the wastage of a power or wastage of some amount of energy which is being used in the process. So this is how a final architecture of IoT and analytics has been used. And this is the conclusion. As I believe that the data generated from IoT devices turns out to be very valuable if subjected to the analysis, and the data analytics into the picture. The data analytics is defined as a process which is used to examine the big amount of data and data sets to extract meaningful conclusions and actionable insights. So these conclusions are usually in the form of trends, patterns, statistics, and these outputs will definitely benefit, and they are fruitful for the business organizations who proactively engage with the data and implement effective decision making process. So this is my second extra credit presentation for this semester. So I'd like to know if there are any queries. And yeah, these are the references I've used for this particular presentation. Thanks a lot.